Now I'm going to quickly describe those key considerations to consider when constructing a map, with the idea that, okay, I realize that not everyone's going to become a cartographer and actually start doing this, but it's going to become more common. It's going to become more typical for you to have actually the ability to make your own maps. And of course, because maps can lie, we got to make sure we understand some key things. First off, the map type. Now that we understand the different types of maps, let's look at it and kind of can think about, okay, well, which one would be the best to showcase a particular data set? In this case, this is showcasing where, at the state level, African Americans live. And so the proportional symbol map, I think this is useful. It definitely shows the patterns, first off on the East Coast, but particularly there along the Atlantic, you see bigger circles, thus more African Americans found in those particular areas. Here's a dot map, which, typically would actually be pretty good for showcasing where people live. But in this case, the dot map doesn't actually show the dot where people live. What it does is it just calculates for the state the total. And so it then scatters those dots throughout that, essentially that state, throughout that area. So for example, if you look at California, most of the African Americans live just in San Francisco or Los Angeles, big urban areas. And so they're mostly found just in one particular or two particular areas. But this map makes it look like they're all scattered throughout California. And so in this case, the dot map, when we think about what map type, isn't as useful as the previous proportional symbol map. Of the maps here we're looking at for African American population in the United States at the state level, I would argue this is the best option, the choropleth map, because it shows those key areas. Just like the proportional symbol map, those key areas are those states in which African Americans are in a much larger proportion of the population. But what the proportional symbol map, the first one, what we saw, what it kind of hid was the fact that we couldn't see that West Virginia, Kentucky, Indiana have a lower percentage or a lower number of African Americans in those states, because the other circles for the other states were so big, it kind of hid those other underlying smaller states. And so of the three, I would argue the choropleth map is best because it shows more of a nuance, more of both sides of the data, not only showing those areas of large numbers, but also the states with lower numbers. Now, map projection. This only matters, map projection, like I mentioned, only matters when we're looking at things at the global level. If you're making a map of Indianapolis, the projection, it really doesn't matter. But when you start getting bigger, moving out, or I should say zooming out from Indiana, the national level, the hemisphere, the entire globe, then that's where projection plays a key role. And I'll show you instances of this right now. As I mentioned before, the difficulties of moving a ball, a sphere, and putting it on a flat piece of paper, it's going to cause a distortion. It's going to cause lying in some regard. So when we look at these different projections, I'm going to go through them very quickly. And I want you to kind of look at how different continents, different areas, different land masses, their shapes might change, the sizes might change. And thus, you can see how the distortion differs from one projection to the next. Here we have the Mercator projection, and so what it's distorting, what it's screwing up, let's say, what it's causing not to be accurate, are the size of continents and land masses. So for example, at the bottom, Antarctica, much bigger here in the Mercator projection than it is in reality. Greenland, up at the top, that big island, much bigger in this projection than it is in reality. So then what's its purpose? If it shows everything screwy, then why is it useful? Why is it useful? Because it accurately depicts the coastlines or the shapes of continents and land masses and countries. So why is that useful? For sailing purposes, for nautical purposes. You could care less about what's going on the land. All you care about is the coastline in the shape of, because you want to go to your destination and get to the exact right location. Further, this map has been used previously for propaganda purposes, and so the Soviet Union, or what is today mostly Russia, over here on the top right-hand side of this map, was much bigger than it is in reality. And so what they did was they used this as propaganda. The government said, hey, Soviets, look how big we are, to try to kind of get the, drum up patriotism. It wasn't so much to show fear in the rest of the world. Hey, rest of the world, look how big we are. It was more to show their own countrymen and women how powerful or big their country actually was. And so here what we have is we're lying, especially when we get closer to the poles, the size of a particular landmass. Here we have the Robinson projection. Of all of them, probably the most popular and most widely used. What's going on here is it distorts in every regard. It distorts shape, distance, direction, area, but what it does is it doesn't distort those as much. It just kind of conforms to them all. It gets a little slight distortion in each of those different characteristics. And so, for example, the area, for the most part, it's accurate. Antarctica down at the bottom, it really isn't that big. Greenland's a little skewed. So it really gets accurate right through the middle of the map. Right through the middle of the world, where a lot of people live. So this is probably why it's widely used. Where we see another distortion is at the top and the bottom. The pole, North Pole and the South Pole, it ain't a line. It's a dot. It's an actual point. And so this is a distortion where it's showing the North Pole and the South Pole as lines when they're actually points. So then this is the solution to that. This is the sinusoidal projection. And so what we have here is we now have a equal area map. So this accurately shows the size, but it also has that situation where the North Pole and the South Pole are accurately shown as points, where all those lines of longitude all come together and meet at either the North Pole or the South Pole. But what it gets wrong, what it's distorting, is definitely distorting the shape, but also the direction. So it gets right the size, and it also gets right that whole North Pole, South Pole thing, but it really distorts the shape, especially the farther you get from the prime meridian and the equator. And so here, the distortion is less in the middle of the map, but as you get farther away, I should say, it gets more distorted. Another key consideration is simplification. So essentially, the quick 411 here is there's all this stuff that we could map. Only map the stuff that's important. And so it's all about, well, what's the purpose of the map? And so you think about what your purpose is, and then you just focus in on those key elements from that map. A great example of this is subway maps or train maps, because they just show if you're riding a train, you don't need to know everywhere all the gas stations are. You don't need to know all the road networks. All you need to know is where to get off your subway line, where do you get off your train, where do you get onto the next train. So you're only focusing in on those key details. And so simplification, omit or get rid of anything that is unnecessary. So here's some examples of simplification. On the map on the left is a highway map. And if you're cruising around Indiana, going all over the state, then that one on the left would be probably useful. But if you're a traveler, if you're a truck driver, just kind of coming through the state, just kind of coming and going, really not going to stay here, then the map on the right is a much simplified version, has less noise, has less excess stuff going on. For example, if you don't need to know where Kokomo is if all you're doing is riding the highways and interstates, because there ain't no highway, there ain't no interstate that goes through Kokomo. And so essentially, we can see simplification, focusing in on what's the map purpose, and then focusing on just those key elements that are necessary. Which we can further see here, the Metro Indy map. So one on the left, cool, great if you want to know all those little nuances, but on the right shows a much clearer, simpler way to showcase Metro Indy. Next up is scale. And so previously when we looked at scale, we also looked at it in terms of a thing that's on the map, one of the 7 key elements of the map. Now when we think of scale, think about this as far as how much do we zoom in and do we zoom out on whatever we're mapping. Do we zoom to the national level? Zoom into Indiana? Or zoom into Indianapolis? And so this is scale. And so we essentially, when we zoom in, that's a certain scale. We can see how we have much more detail in this map. But when we zoom out, that's a much bigger scale in which we're now looking at the entire country or the entire world. And so that's what scale is in this perspective. This is how much do we zoom in and do we zoom out. And why this is of use is because throughout the semester, we're going to look at things at different scales. And so when we think about, for example, the impact of globalization at different scales, well, the impact of globalization on Indianapolis, the impact of globalization on the United States, the impact of globalization on the world. And so we can see how when we think of scale, when I use scale, we're going to refer to it as a few different things in terms of an actual element on the map, but also what level are we referring to when we look at the impact of something, or in this case, the particular map of where people live, whether it be Indiana and the United States and our good friend Canada. And now at the global level. And so once again, scale, we're going to look at different areas. Do we look at the globe? Do we look at the nation? Do we look at the state? Do we look at the city? Do we look at the township? So this kind of shows you how we can look at different areas at different zoom in levels, let's say. Finally, aggregation. This one often can be confused with scale, so hopefully my examples will help separate the differences. Now when we look at aggregation, we're focusing in on the geography or the data that's being mapped. And so this is a map that shows poverty at the state level. From this we can see that there's certain states, particularly in the southern part of the United States, in which poverty is at a much higher rate than other areas, particularly the northeast coast and the northern Great Plains. However, when I change the data, when I change the aggregation, so essentially I disaggregate, I now go to the county level. So now previously, if you notice, we didn't zoom in or zoom out. Now all it's changed is the data has gone from state level to county level. Now we can have a much clearer depiction as far as where poverty is in the United States. We can see within those individual states that were previously shown as being having higher poverty rates, we can see specific areas. And so this is probably when we think about aggregation, in this case, by looking at the county level, changing our geography as far as our data, we can now see a much clearer depiction as far as where poverty is in the United States.